Hello everyone, welcome to the solution of LeetCode problem 735 named Asteroid Collision. In this problem, we are given an array of asteroids of integers representing asteroid in a row, and for each of the asteroid, the absolute value represents its size and the sign represents its directions. Here, positive means right direction and negative means left direction. Now, each asteroid moves at the same speed. We have to find out the state of the asteroid after all collisions. Here, if two asteroids meet, the smaller one will explode. But if both of the asteroids are the same size, then both will explode. Now, two asteroids moving in the same direction will never meet. Here, if we see that in the first example, the asteroids are 5, 10, and -5. Here, 5 and 10 are moving to the right, and -5 is moving to the left. So here, this asteroid 10 and this -5 will collide, and -5 will disappear. So finally, the remaining asteroid will be 5 and 10. So here, 5 and 10 is remaining. Now, in the second example, the asteroid are 8 and -8. So here we can see that if both of the asteroid collides, then both of them will exploit each other. So we can say that the output will be an empty list. I hope you understood the problem statement as well as the examples. Now the constraint are, here the asteroid lengths can be in between 2 to 10 to the power 4, and each of the element in the array can be in between -1000 to +1000. And the asteroid's value cannot be equal to 0. I hope you understood the constraint. Now let's move on to the code or the algorithm. Now, to solve this problem, we have taken another example. Here, the array contains 5 asteroids, which is 1, 2, 3, -2, and -3. Now here, asteroid 1, 2, and 3 is moving to the right direction. Now, asteroid -2 and -3 is moving to the left direction, which is this. Now, here, for this pair, 3 and -2, when the asteroid 3 and asteroid -2 collide, the asteroid -2 will become vanished. So here, only 3 will remain. Now, after that, for this pair of the asteroid, if asteroid 3 and -3 will collide, then as both of them has the same strength, then here, both of them will become vanished. So 3 and -3 will become vanished. After that, only asteroid remain is 1 and 2. So in this test case, we have to return 1 and 2. Now let us understand how can we solve this problem by using the stack data structure. So here, to solve this problem, at first, let us take one stack data structure. Now, we have to iterate all of the element from left to right into the given array. Suppose if currently our position is this element, which is 1, so it is positive, right? So we should insert this element 1 into the stack. So we are inserting 1 here. Now, for this element 2, we should insert it at the stack. Now, for this element 3, as it is positive, we have to insert it into the stack. Now, for this element -2, we have to check several conditions. Now, as it is -2, that means its direction will be towards left, and the previous element's direction is towards right. So there is a possible collision. So now we have to decide which of the asteroid will become vanish. So the nearest possible asteroid for this element -2 will be the top element of the stack, which is 3. Now, if asteroid 3 will collide with asteroid -2, the -2 will become vanished because the strength of -2 is 2, which is less than the element 3. So here, these two will be vanished. So now, our current pointer is pointing to this element -3. So here again, our top element is 3 and our current element is -3. So the direction of this element -3 is towards left, and the recent top element of the stack's direction will be towards right. So there is a possible collision, right? So the current element will be -3 and the stack top element will be 3. So if the collision happens, both of the 3 and -3 will become disappeared because according to the rules, if the strength of the asteroid is equal, that means both of the asteroid will become vanished after the collisions. So here we have to remove the top element of the stack, which is 3. After that, we have seen that we are remaining only 2 elements in the stack, which is 1 and 2. So if we extract the element 1 and 2 from the stack, we will find a list or the array, and it is the resultant output. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named asteroid collision, which has a vector as a parameter, and it will return a vector as a return type. Now, we are using one stack and we are iterating all of the element of the given input. Now, we have to check whether the current element is greater than 0 or not, or our stack is empty or not. If any of the condition is true, that means we have to simply insert the current element into the stack. Otherwise, for all of the negative element, at first we have to repeatedly check whether our current stack is empty or not, and the top value of the stack is greater than 0 or not, and the top value of the stack is less than the absolute value of the A of I or not. If it is, there is a possible collision of the positive and negative element, then we have to simply remove the top element of the stack. Otherwise, here we have to check whether the current element is equal to the stack top element or not. If it is, we have to simply remove the top element of the stack. After that, we have to check whether our current stack is empty or not, and the top element of the stack is less than 0 or not. If it is, that means we have to simply insert the current element into the stack. After that, we have to make a vector with the remaining element in the stack and finally return the answer. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate each of the element of the given input, and the space complexity is also big O of n because we are using extra memory answer to store the result. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.